Okay, so we are going to go ahead and jump right into section 1.1. So I'm going to share my screen with a PowerPoint. I'm going to tell you guys to take notes. I even have some parts, like when I do this in the classroom, it's kind of half PowerPoint, half me writing on the board. There's lots of studies that have been done that have shown that if you write down things yourself and you see me writing it on the board, then it helps you remember things better. So I'm going to try to mimic that in this virtual environment here. I'm going to end up typing things on the screen, and I want you to be writing those down like you were taking notes in class, because that's exactly what you're doing. So let's see. Here we go. All right, so first of all, so see, this is this down part. I'm gonna start putting like typing on the screen instead of writing on a chalkboard. I could write on the computer, but you guys would probably not like my computer handwriting that well. I will write on there sometimes, but it's not pretty. Okay, so first of all, let's talk about statistics. Okay, when you hear the word statistics, what do you think of? Okay, and go ahead and type your answer in the chat window. So when you hear the word statistics, what do you think of? Okay, a lot of people said data so far. Nerd, haha, I like that one. Lots of data, graphs, numbers used to present data, collecting and analyzing data. Those are all great answers. Yeah, so that's all of that encompasses statistics. So if we're going to define statistics, then statistics is going to be the science of collecting, analyzing, and interpreting data. So statistics is the science of collecting, analyzing, and interpreting data. All right, so we're going to start by talking about collecting data. Okay, and this data that we're collecting we're taking measurements on individuals, and we call those individuals the cases. Okay, so our next term is cases. Okay, and cases are the individuals described by a set of data. So cases are the individuals described by a set of data. So cases can be people. A lot of times when they're people, we call them subjects, but they don't have to be people. Cases could be plots of land or cows or cookies or widgets or anything. Okay, so whatever it is that we're taking all these measurements on, that's what we're going to call our cases. Now on these cases, we're collecting all this information, and that information, we call those the variables. So the next term is variable. And a variable is any characteristic of an individual or case. So a variable is any characteristic of an individual or case. So any characteristic of an individual or case. All right, so variable, any characteristic of an individual or case. So these are the things that we're measuring on those cases. And we have two basic types of variables. So there's two types of variables. Okay, the first one is called categorical. So a categorical variable is the first type of variable. Okay, a categorical variable is going to place an individual into a group or category. So places an individual into a group or category. Okay, so a categorical variable is going to be something like eye color or hair color or ethnicity, or gender, okay, something like that, something that's going to place you into a group or a category. Okay, the other type of variable that we have is quantitative Okay, a quantitative variable is going to take numerical values for which arithmetic operations such as averages make sense. So quantitative variable takes numerical values for which arithmetic operations I can't spell, so that's supposed to say arithmetic, but you know, it's not giving me a spell check on here, so I'm in trouble. Okay, I'm just going to say math operations. How about that? For which math type operations make sense. All right, so quantitative variables are going to be things like height, weight, distance, temperature. Okay, so all those are going to give you a number type of result, and it makes sense to talk about average height or average weight or average distance, something like that. All right, so just real quick in the chat window, can you give me an example, not one that I just used, but your own example of a categorical variable? So what's something you think is a categorical variable? Preferably one that I didn't already say. Okay, shoe type, brand, occupation. Okay, school, those are all really good things. Favorite something. Hair color. Favorite flavor of drink, definitely. Music preference. Okay, good. These are good things. Okay, what about quantitative? Okay, so what would be an example of a quantitative variable? Good, so I'm seeing like age, shoe size, grade on a test, number of siblings, IQ, velocity. How many old people live in a particular city? That's a creative one. I haven't seen one like that before. Number of things. Okay, so good. Those are all going to be quantitative type variables. Okay, so if you're ever wondering whether something is categorical or quantitative, then I have two questions that I always ask. So I'm going to delete the top part here and I'm going to type these down here just in case you're still writing the other part. So I always ask these two questions. Okay, the first question I ask is it a number? Okay, and the second question I ask is, would it make sense to talk about the average, fill in the blank with whatever the variable name is? So would it make sense to talk about the average, and then I'm just going to say fill in the blank, okay, with whatever your variable is. If the answer to both of these questions is yes, then it's a quantitative variable. And if the answer to either of these questions is no, then it's a categorical variable. So if the answer to both questions is yes, variable is quantitative. And if the answer to either question is no, the variable is categorical. All right, so kind of looking at some of these variables, we can try out this test on there. So like if the variable is grade on a test, okay, well, is that a number? Yes, if we're talking about, you know, like 95%, that kind of thing. So yes, it's a number. Does it make sense to talk about the average grade people in our class got on the exam? Yes, so because the answer to both those questions is yes, it would be a quantitative variable. If I'm looking at gender, okay, is gender a number? No, okay, so it's not a number, which means that it's definitely a categorical type variable. Sometimes people get a little bit confused with some variables, like age or income can be confusing ones. Mostly because sometimes there's some surveys that kind of try to turn those into categorical variables, but really, if you look at just the variable age, you know, is age a number? Yes. Does it make sense to talk about the average age for people in our class? Yes. So that means that age is a quantitative variable without getting any other information. Okay. So an example of something that might be a number but is still a categorical variable might be something like area code. Okay, so area code on your phone number is a number, but does it make sense to talk about the average area code? No, not really, right? Or zip code, same thing. Like zip code is a number, but you don't really talk about the average zip code for Texas or something like that. Like that doesn't have any meaning. So so zip code would be categorical in that case. All right. Questions so far? Okay, good. One more definition before we start looking at a couple examples here. Okay, I'm just going to delete the top part here in case you're still writing things down. Okay, so next definition is data set. Okay, so we have these cases, we have these variables, and we have all this information that we're collecting, and we're going to organize it into a data set. Okay, so data is usually presented in a data set. That's basically just all that information together. So in a data set, typically the rows represent the cases and the columns represent the variables. So typically the rows in a data set represent the cases and the columns represent the variables. Okay, so in a data set, each row would be a different case. And then all the things that we're measuring on those cases are going to be represented with the columns. So I'll give you another couple seconds to finish writing that down, and then we're going to look at a couple examples. And if your camera's off, go ahead and turn that back on so that I can, that's how I'm looking to see whether people are still writing or not writing. All right, so we'll go ahead and check out some examples now. My mouse. Here we go. So here's the first example. Okay, here's my data set. Some information that they've collected here. So what do you think are the cases in this data set? So remember, the cases are the individuals described by the set of data. So what do you think the cases are in this data set? Yeah, good, exactly. So the countries are the cases in this data set. And I did notice I missed a question in the chat window. Somebody asked if sometimes data sets are flip-flopped with the cases being in the columns and the variables being in the rows. Yeah, sometimes it is, but in general, it's done this way. And in all the data sets you're going to use in our class, it's going to be the cases are the rows and the columns are the variables. All right, so so the countries are the cases here, and they measured lots of variables on each of the countries. So what are one or two of the variables that they measured? Yeah, population, gas pump prices, land area. Okay, they were measuring like the percent of rural areas in that country, the population density. Okay, so those are all the variables that they measured here. Okay, here's another one. This one's a little bit harder. Okay, so This is a survey taken of an intro statistics class where they asked them a bunch of information. Okay, so what are the cases in this data set? Okay, I'm seeing a lot of answers, but I actually have not seen the correct answer yet. Oh, I finally saw it. I saw the correct answer. All right, so remember that the cases are the individuals described by the set of the data. So this is who we're taking measurements on. So who did we take measurements on in this survey? Each row in this data set represents one student, exactly. Okay, so one row represents one student, so the students are the cases. And what makes this one a little bit tricky is that on the previous one here, we actually had an identifying column that, you know, gave the name of each case, essentially the name of each country. Whereas on this one, we don't have that, okay? We just know that each row represents a different student. So year is actually one of the variables rather than being the name of the cases, because we didn't take measurements on junior, we took measurements on the students. All right, so what are some of the variables in this data set? If the cases are the students, what are some of the variables? Okay, good. There's all kinds of things here. Okay, so GPA, award, SAT scores, height, gender. Okay, so those are all the variables here. So this one has a mix of categorical and quantitative variables. Looking at the types of answers that we're seeing here, give me one of the categorical variables that they measured here. So what looks like a categorical variable that they measured in this data set? Okay, good. Gender, higher SAT, what type of award they would prefer to win. Okay, good. Okay, what about quantitative? What would be a quantitative variable from this data set? Okay, good. Number of siblings, GPA, height, weight, a number of hours exercised, exactly. So all of those are going to be quantitative type variables that they measured here. Okay, next example. Okay, this is an experiment that they did to see if like diet soda caused you to excrete more calcium. Okay, so what they did is they had a group of subjects. They assigned half to drink. I don't know exactly how much they had to drink, but let's just say, you know, half of them drank like 10 cans of Diet Coke a day, and the other half drank 10 cups of water a day. And then they measured how much calcium was excreted. And so that's basically what this study is. So thinking about that, this is the data from that study, the data set from that study. What are the cases in this data set? Ah, good, you guys are good. So this is, the cases are the individuals. You could call them the subjects because we did an experiment, but it's all the people that participated in this study. So the people that were doing the drinking. And then in this case, they had two variables. So what were the two variables that they measured on each of the cases? Okay, so one is which beverage they drunk, right? So the type of drink, and then the other one is how much calcium was excreted. So the Diet Cola and water is actually part of the same variable. So it's just one variable, but it has two levels, diet soda and water. Okay. All right, so we can use data to help us answer questions, which is often why we collect data. So here is a question. I want you to just think about what your answer is right now. So if you are romantically interested in someone, do you think that you should be obvious about it, or should you play hard to get? Okay, so I am gonna see if we can collect some data here. Okay, I'm gonna do a poll this time, so not in the chat window, but I just launched a poll. So hopefully on your screen, it should have popped up a poll somewhere and you should be able to choose. So click on A if you prefer somebody who's obviously into you, and click on B if you prefer somebody who plays hard to get, like when you're in a relationship or starting a relationship, I guess. Okay, and this is all anonymous, so nobody's gonna see what you put on there. Is there a third option for cheap dates? Just 2 options today. Okay, we got most people voting on there. I'll go ahead and share those results with you guys. Okay, so here's what we got. So about 81% of the class said that they preferred somebody who was obviously into them, and about 19% of the class said that they preferred somebody who plays hard to get. So most people are preferring the obviously into them. All right, so that's one way that we can collect data, but we might be interested in knowing, hey, does it depend on whether you're male or female? Like, does it make a difference? In other words, does it make a difference whether we're talking about males or females, what they prefer? So now I'm gonna relaunch the poll, and we're gonna start with just the males, which I know we don't have a lot in our class. Our class is definitely predominantly female, okay, but just the males are gonna vote this time on what they think. And we're gonna see if the breakdown looks different depending on whether we're looking at males or females. All right, so just males voting. I think we got everybody, so I'll end the polling. So this is just the males, and it does look a little different than our overall results. We can see that 67% of males, so about 2/3, said that they wanted somebody who was obviously into them, and 1/3 said they preferred somebody who is hard to get. All right, so now let's look at females. Whoops. I think I forgot to share the results. That's okay, I told you what they were, so here, I'll share them real quick. Okay, there's what the results look like. Now I'm gonna relaunch it for the females. Okay, so now females only vote on what you think. Okay, awesome. So I'll share these results for real this time. Okay, so for the females only, we've got 85% where they wanted somebody obviously into them, and 15% where they preferred somebody who is hard to get. So based on the results of our class, it does seem like it's different depending on whether you're a guy or a girl. It seemed like it was a little bit more likely for the guys to want somebody who plays hard to get. So that's interesting, okay? That's when we start looking at relationships between variables. So when we're looking at relationships between variables, like this one, we're looking at the relationship between gender and their preference of obvious interest or hard to get. Then we like to give those variables different names so we can kind of distinguish between those two variables. So we're going to write this down. Turn on my writer here. Okay, so I'll just say looking at relationships between two variables. Okay, so we're going to give them distinct names. I'll say that. Okay, so the first one is going to be the explanatory variable. Is that what I want to define first? Now let's define the response variable first. The first one is the response variable. Okay, so the response variable is the variable that we're trying to understand or predict. So the variable we are trying to understand or predict. And if you've taken a science class or anything before, the response variable is also known as the dependent variable. Or even a math class, we call it the dependent variable there too. Okay, the other one we call the, whoops, I don't know how that popped up there. Okay, the other one we call the explanatory variable. And the explanatory variable is the variable we're using to help us understand or predict the response variable. So it's the variable we are using to help us understand or predict the response variable. Okay, so in scientific terms, we call it the independent variable. And my kids are all in 8th grade. Well, not all my kids, but 5 of my kids are in 8th grade right now. And since they're all doing online school, that I hear what's going on in all of their classes all the time. And they were just talking about these exact things the other day, the independent variable and the dependent variable. I was helping them with their science experiment that now, of course, they have to do right here in my house. And we were identifying those. So you guys can probably remember back to those days. Okay, so with these definitions in mind, trying to see if make sure everybody got a chance to write those down. I can see a couple people still writing. So I'll give you another couple seconds, and then we're going to look at some examples and see if we can figure out which one's the response and which one is the explanatory. All right. Okay, so we're going to look at these examples here, starting with number 1, okay? So the question in number 1 says, can eating a yogurt a day cause you to lose weight? Okay, so first let's see if we can identify the response variable. I usually think it's easier to find the response variable first and then figure out the explanatory. So remember, the response variable is what we're trying to understand, what we're trying to predict or estimate. So what's the response variable for number 1? Okay, good. So that one's the weight loss, right? Or the weight, okay? So what's the explanatory variable here? What are we trying to use to help us understand weight loss? Yeah, exactly. Whether we eat yogurt or not that day. So eating yogurt is going to be the explanatory variable, and then weight loss would be the response. Okay, question number 2. Do males find females more attractive if they wear red? Okay, so what is the response variable here? What are we trying to understand? Okay, good. So our response variable is attractiveness, level of attractiveness. However, you're going to measure that maybe on a sliding scale or something. Okay, and what's the explanatory variable here? What are we trying to use to explain attractiveness? Yeah, wearing red. Exactly. Good job. Okay, question number 3. Does louder music cause people to drink more beer? Okay, so what's our response variable here? Right, beer consumption. So how many beers you drink, maybe you'd measure it that way. And then what would be the explanatory variable? Yeah, how loud is the music? So we're going to look at the loudness of the music and see if that can explain how much beer people are drinking. Okay, and last one, number 4, are lions more likely to attack after a full moon? Okay, so what do you think is the response variable for this one? Good. So the lion attacks is the response variable. And then what are we trying to use to explain the lion attacks? What's our explanatory variable? Full moon, exactly. Good job. Okay. Awesome work, everybody. So we are only 2 minutes left of class. What I want to do for the last 2 minutes is there is a student demographic survey. Some of you already saw it, I know. I'll pull up my screen in Blackboard and see if I can find it for you. So if you look in the week 01 folder, and you scroll down all the way to the bottom, there's this demographic survey. This is different from the student information survey that I've already sent out to you. So this demographic survey is anonymous. It's going to ask you a bunch of questions, and then we can kind of use the answers to those questions to look at different data throughout the semester. So it's just going to be fun that way. So if you would just take a couple minutes and fill that out, then that would be super fantastic. And we'll start next time by kind of talking a little bit about the survey and the types of variables that were measured on the survey. You should just be able to, again, just go to the week 01 folder and then scroll down to demographic survey. And then if you click on that, then it'll bring it up and let you start taking it. All right, so does anybody have any questions about anything that we talked about today or anything? Okay, excellent. Then before we meet next time, if you could try to get onto Wiley Plus so that I know if you have any problems getting on or anything, then that would be great. You could go ahead and do the homework assignment in Wiley Plus for section 1.1 if you'd like. And then again, if you could just fill out that demographic survey. If you haven't done the student information survey, I also would love you to fill that out as well. So I'll hang around for a while after class if anybody has any questions. If not, then I will see you guys all on Thursday.